All right, what's up, guys? We had a number of guys absent from class on Friday, on Thursday, that missed the factoring lesson. So I wanted to go back through it. For those of you who maybe were there, this still might be good to watch again, just to go over some of the principles of factoring as far as difference of squares, difference of cubes, and sum of cubes. So I'm starting off by just having these three different scenarios here. If you look right here to the over top of these, I said that A equals X and B equals 7. And underneath of that, I've given you a little formula. It says parentheses A plus B, close parentheses, parentheses A minus B, meaning A plus B times A minus B. Now, if I told you to substitute A equals X, wherever you saw A, substitute X, right? And whenever you saw B, to substitute 7, all right, how would you finish this? You would end up having X plus 7, X minus 7. Right? And if you look at this one right over here, right, if I asked you to substitute X wherever you saw A and 7 wherever you saw B, you would end up getting X plus 7, parentheses, A squared, which is X, so X squared, minus X times 7, right, which would end up being, we have to flip those because we don't have x7, we say 7x minus 7x, right, and then plus b squared plus 7 squared. And if we were to simplify that, we can simplify one of those numbers, which is 7 squared, so we'd end up with x plus 7, x squared minus 7x plus 49. All right, and the last one that we have right up here, again, substitute X wherever you see A, and 7 wherever you see B. So we would end up having X minus 7 times X squared plus A times B, 7 times X, which is 7X, and then plus B squared, which is, again, 7 squared, close parentheses. And if we were to finish that up, to simplify it, we can simplify the 7 squared, so we'd get X minus 7, parentheses, times X squared plus 7X plus 49. Now, what was the point of showing you this? This is, right here, difference of squares without the first part. We have our sum of squares right here. And finally, this is our difference of squares, or excuse me, this is sum of cubes. My mistake there. Sum of cubes. Misspoke. And the difference of cubes. Handwriting is not fantastic. I'll keep working on it. All right. So what does this all mean? It's all great and all. Now, the key is that we need to be able to find what A is and what B is for each of these. And the way that we do that is by identifying what is it. Do we have a difference of cubes? Do we have a sum of cubes? Or do we have a difference of cubes? Okay. So let's go to the first page. And again, these are our formulas for each right here that we're looking at. Okay. For the difference of squares, sum of cubes, and difference of cubes. All right, so let's go back to the first page here. All right, GCF we've done before. All right, so I'm going to skip down to these problems right here. Okay, so look at this. This says a difference of squares. So what does that mean? It means a difference, which is why we have the subtraction sign there, of two perfect squares. So A squared is representing a perfect square, and B squared is representing a perfect square. And if you have those, okay, the rule for perfect squares is, if you have two perfect squares, A squared minus B squared, all right, two perfect squares that are being subtracted, if you can find A and B, whatever A and B are, all you have to do is plug that into the formula A plus B times A minus B. And if we were to FOIL it, we would end up getting the exact same thing that we started with. All right. So look at number 3 here. 9x squared minus 49y squared. Is 9x squared a perfect square? Yes, 9 is a perfect square. What number multiplies together twice to end up getting 9? 3. 3 times 3. What number ends up multiplying twice to get x squared? X. X times x is x squared. So this meets our criteria for a perfect square. And then 49y squared. Is 49y squared a perfect square? Well, 7 multiplied twice gives us 49. Right? And y multiplied twice gives us y squared. So this as well is a perfect square. Now, how do we figure out what a and b are? Well, let's look at the first term. We can assume that if this is a perfect square right here, whatever the square root of that perfect square is will give us a. So what number multiplies together twice to get 9? 3. And what number multiplies together twice to get x squared? X. That's us basically taking the square root of the first problem. So if you were to put a square root over it, boom, that would give you a. 49. What is the square root of 49? And this, by the way, is going to represent our b once we take the square root. So b equals 7. 7 times 7 is 49. Y, because y times y is y squared. So now we have a and b. All we have to do is look up at our formula that was given to us, a plus b times a minus b. It really doesn't matter what order the signs are in, as long as one is plus and one is minus. So let's go ahead and plug them in. Instead of a, we're plugging in 3x. Instead of b, we're plugging in 7y. So we end up getting 3x plus y, 7y, and 3x minus 7y. Excellent. And we're done. That's it. All right. So the key is for difference of squares, sum of cubes, and difference of cubes is to identify, are they perfect squares? Take the square root of each number. The first term represents our a, and the second term represents our b once we take the square root, or the cube root once we get down here. If you see I'm underlining cubes there. Once we get to perfect cubes, we need to change our mindset and use cube roots instead of square roots. Okay, so yes, you need to be good at identifying perfect squares. All right, so what are the perfect squares? Well, you guys should have a list of perfect squares. What are our perfect cubes? You guys should have a list of perfect cubes, both numerical and algebraic. All right, meaning both numbers and the variables as well. All right, so make sure you're looking for that and have that out while you do this. It'll make your life a lot easier. All right, so let's look at number 4. 72c to the 4th minus 2. All right, well, 72, what number multiplies together twice to get 72? There is not a number that multiplies together twice that perfectly will go into be 72. And same goes for 2. All right, so looking at this, the first thing that we always have to check before we factor is for GCF. And the GCF here, what number goes in both 72 and 2? 2. So we're going to take a GCF out of 2. Once we do that, so let's go ahead and take out that GCF, divide both of the terms by 2. We end up getting 36c to the 4th minus 1. All right, that's a 6 right there. 36c to the 4th minus 1. All right, now that we've taken a GCF out, we need to make sure that we do have our GCF sitting on the outside of the parentheses. All right, for the rest of this, that's just going to be there, but we don't have to focus on that at all. All right, what we need to focus on is the inside of the parentheses. All right, so is our first term inside of the parentheses a perfect square? All right, 36c to the 4th. What number multiplies together twice to get 36c to the 4th? Well, that would be our a term, and that number would be 6 times 6 gives us 36, taking the square root. And what number multiplies, or what variable, exponent, multiplies together twice to get c to the 4th? C squared. C squared times c squared using our product rule, we add them together, so it would be c to the 4th. So a equals 6c squared, and then if we do b, which is our second term here, 1, what is the square root of 1? What number multiplies together twice to get 1? 1 does. 1 times 1 is 1. So now we have a and we have b. All right, so I'm going to go ahead and get rid of this guy for a second so that we can continue our problem down lower. Don't have space here and I can't zoom in. So it makes it a little bit difficult. So I'm going to go over 2 of these problems each, and if you're still struggling with a certain type, I can even go further with you. All right. So now we have A. We took the square root of our first term, 36c to the 4th. All right. 6 multiplies together twice to get 36. C squared multiplies together twice to get c to the 4th. And 1 for B, for our B term, 1 multiplies together twice to get 1. All right. Again, it's a difference of squares because it's subtraction sign in between the 2 terms. All right. I wish I could say, do you understand so far? All right. Let's move forward then. So now we need to put it into our formula. A plus B times A minus B. So A is 6c squared. So let's go ahead and set this up. 6c squared plus B is 1. And then 6c squared minus 1. And are we done? That's a question that we need to ask ourselves every single time before we do this. And I'm also forgetting one thing. The GCF needs to be on the outside, so that 2 has to carry down. And let's make sure we don't forget that. Put that on the outside. Are we done? We have to look at each factor. Right? We have 3 of them here. All right? 1, 2, and 3 factors. Right? They're being multiplied together. That's what the definition of a factor is that we've gone through. All right, so the question is, do we have any perfect squares? Do we have anything else that we need to worry about? Well, this is close. All right, c squared is a perfect square, and 1 is a perfect square. However, 6 is not a perfect square. So there's nothing else that we can do here. This is all fully factored. So we have our final answer there. So I'll go ahead and circle that, and we will call it a day for difference of squares. Okay, again, how do we figure these out? We have to identify, first of all, if there's a GCF. If there is a GCF, once we take it out, do we have a difference? What does that mean? Subtraction. Okay. Do we have a difference? Yes. And then is each of the terms that are being subtracted, are they perfect squares? You have to really be able to identify whether or not they are perfect squares. And if you can do that, then you take the square root of the first term to get A, the square root of the second term to get B, and then you plug it into the formula that's been given up here at the top. Okay. I'm going to move down to perfect cubes. All right, again, our perfect cubes. If we look at our list, 1, we have 8, we have 27, we have 4 times 4 times 4 is 64, we have 125, 5 times 5 times 5, we have 216. And then as far as for variables, anything that is a multiple of 3, so any exponent that is a multiple of 3, so x to the 3rd, x to the 6th, we'll put an x to the 9th down here, x to the 12th, x to the 15th, x to the 18th. Okay, all of those are also perfect cubes. All right, but when we're talking about cubes, we can't think of in terms of square roots because that is not the right realm here. Okay, we need to think of cube roots. All right, when we're doing this. So the rule here, all right, if we have a perfect cube, and notice that this is the sum of cubes. If we have a perfect cube plus another perfect cube, and that's all this represents, all right? A cubed and B cubed all represent perfect cubes, all right? If we do that, if we take the cube root of the first term, we would need, and the second term, we would need to plug it into this formula. A plus B times A squared minus AB, and then plus B squared. All right. So this is the formula that we need to use here. But again, what do we need to find? We need to find what A and B are. So they're hidden inside of the problem. So let's look at number 1 here. Okay. We have a sum. And do we have 2 perfect cubes? Well, x cubed, x to the 3rd. That is a perfect cube, right? And then plus 27. Is that a perfect cube? If you look up at the top here at our list, yes, 27 is a perfect cube, right? So what number multiplies together twice to give us this x cubed here? Or excuse me, 3 times. What number multiplies together 3 times to give us x cubed? That is essentially taking the cube root, right? Well, a would equal x. X times x would give us x cubed. So we're taking a cube root of the first term to get A, and then taking the cube root of the second term to get B. All right, so what number multiplies together 3 times? 1 times 1 times 1 gives us 1. 2 times 2 times 2 gives us 8. 3 times 3 times 3 gives us 27. So the cube root of 27 is 3. All right, so now we have A, equals x and b equals 3. What we need to do now is plug those back into this formula right here, and that will potentially give us our final answer as long as we don't have anything else that we need to factor once that's done. So, A is x, so x plus 3, just plugging it right in, times a squared, x squared now, just using substitution, minus a times b, minus x times 3, which would end up being 3x. We always put the coefficient in front. And then finally, plus 3 squared. And we would need to simplify that. We'll end up not doing this problem. We'll do the one right below it. All right, so we need to simplify it. This part right here, this is not simplified yet. All right, we need that to be a 9. So we'll just go ahead and rewrite it as x plus 3 times x squared minus 3x plus 9. Again, I'm sorry for the sloppy writing. Doing the best I can with what I got right now. All right, looking at number 9. All right, this is our final answer. If you look at this, there's nothing else I can do. I could try trinomial factoring, all right, and that's something that you should attempt. All right, but what are the factors of 9? Well, we have 1 times 9, all right. This would be a negative 9 if we were doing our trinomial factoring. 1 times negative 9, both would be negative. Negative 1 times negative 9 gives us 9, but if we add them together, we get negative 10, and the other factors that we could use are negative 3 and negative 3, which would give us a 9, but when we add them together, we get 0. So none of these equal b, so we are done. All right, but notice that I at least tried to make sure that there was no trinomial factoring available here. All right, that's something that you always have to check. Otherwise, you may not have the complete answer. All right, let's move on here. I am going to go ahead and wipe this problem out, all right, so that we have space to do this one here. All right, so let's look at the next problem. 504, all right, 500a cubed and then plus 4. So again, it's a sum, yes, all right, but are they perfect cubes? No, all right, they're not perfect cubes, because 500 is not a perfect cube and neither is 4, all right? So looking at the two terms, we do have a GCF, and that's what we need to take out first. All right, so I'm going to take out the GCF, which would be 4. GCF is 4, all right? And you can, again, figure that out using a calculator. If you divided 500 by 4, right, you would end up getting 125. So we're going to put that 4 on the outside, and remember what I said, once we take the GCF out, we need to keep that on the outside of the parentheses throughout the entirety of the problem. All right, so we're left with 125a cubed plus 1. Now, look at these two terms. Is this a perfect cube? Look up at the top here. 125 is, and then we know that any multiple of 3 is a perfect cube, so a cubed is also a perfect cube, and 1 is also a perfect cube. So yes, this does fit the criteria. All right, so now we just need to figure out what a and what b are. All right, so what is a? A, just looking at the first term here, the whole thing, what number multiplies together 3 times to get 125? 5. So we'll put the 5 there. What number multiplies together 3 times to get a cubed? A. And then here we have b. What number multiplies together? This is our b term. All right, what number multiplies together 3 times to get 1? 1. All right, so now we have a and we have b. We have a GCF. We can't forget that. We need to keep that on the outside. So now we can go ahead and plug this in. So I'm going to put the GCF 4 on the outside and just plug it right back into the formula that we have up at the top. A plus b times a squared minus ab plus b squared, close parentheses. So here we go. A is 5a plus 1. A squared is 5a, right? So 5a squared. So again, if you want to, you can go ahead and put it inside another thing of parentheses. All right, this is going to end up being 25a squared, all right? But again, you need to make sure that this 2 is being squared to both the a and also to the 5 as well. All right, we'll get to that in just a moment. But that is just simply our power rule, all right? Minus a times b, 5a times 1 is just minus 5a. and then finally plus b squared plus 1 squared, so it's plus 1. All right, and you could write the 1 squared there because we're going to simplify this anyway. I'll rewrite it underneath, totally simplified. We get 4 times 5a plus 1. Close parentheses, new parentheses. 5a squared is 25, as we use our power rule, a squared, minus 5a plus 1. And we do have to double check to make sure that this can't be factored. All right, in this case, there is nothing else that we can do. There's no trinomial factoring. We, at this point, wouldn't have gone over our special trinomial factoring, which is what we could use here, but it's not possible. Both of these factors are prime, so this is as far as we can go. All right, and that is our final answer. All right, so let's scroll down here now. We're going to look at the difference of cubes, and the only difference between this is there's a little bit of a different formula. All right, so if we have a difference, again, what does difference mean? It means subtraction. Sum means addition. Difference means subtraction. All right, notice that there is no sum of squares. All right, so if you see a sum of two perfect squares, there's nothing you can do about it. All right, there's nothing you can do about it. So again, need to recognize that so that we're not making any mistakes there and doing something that is illegal in terms of math and what we've been learning. All right, so let's go with this first one here. We have a difference. We have two cubes. Let's write our rule out first. If we have a cubed, a perfect cube, minus another perfect cube, which we're calling b cubed here in our rule, we get our formula, and that formula is a minus b. If you look at the top one, it was a plus b. This is a minus b, and then everything else from here is positive. Okay, so a squared, almost identical, a squared plus ab plus b squared. So if you can do a sum of cubes, you really should be able to do a difference of cubes because it's almost the exact same thing, just a slightly different formula. All right, the first one you can see is a plus b, the second one's a minus b. The first one has negative minus ab in the middle term there for the trinomial. This one has plus ab. So very similar. We just need to make sure we're aware of the differences. All right, so let's look at number 11. X cubed minus 1. All right, we have a difference. Now, is this a difference of squares? Is this a difference of cubes? Is it neither? Well, let's look at it. We have x to the third, so that should tell us a lot, right? X to the third, it's a cube, right? X cubed. So that is a perfect cube, and 1 is also a perfect cube. So again, let's take the cube root of our first term and the cube root of our second term. The first term will give us a. The second term will give us b. Okay, so a equals what number multiplies together 3 times to get x cubed? X. And what number multiplies together 3 times to get 1? 1. 1 times 1 times 1 gives us 1. So now we just go ahead and plug them. I'm going to cross this out. We don't need to do that one. We're going to go down and do 13. All right. We end up plugging those right back into the formula. That's given right there. All right. So x minus 1, close parentheses, and then we have x squared plus ab, so plus 1x. 1 times x is 1x, or just x. And then finally plus b squared being 1 squared, which we know is just 1. Okay, so you can go ahead if you want to, if you are figuring it out, pretty well at this point. You don't need to put that 1 squared up here. You can just go ahead and square that number just to get to that next step. If you want to write it out and then simplify it again, that is completely recommended if you're not quite to that point. Right? Now we do have to double check what could potentially be factored here. We don't have anything, no difference of cubes, no nothing there. It's just x minus 1. That can't be simplified any further. But if we look at this, can we simplify that polynomial any further? All right, what are our factors of 1? The only ones are 1 times 1. All right, I'll put them right over here. 1 times 1. 1 times 1 is 1, but 1 plus 1 equals 2, which is not what b is equal to here. So we cannot factor this any further. That is prime, and that would be our final answer. Again, I'm just double checking because you've got to make sure that you're double checking that there cannot be any other factors that can be factored. All right. All right, let's go ahead down to number 14. All right, let's go to that one. I'm sure that there's probably a special case in here. So we'll go down to number 14. All right, and notice we have a difference. All right, but do we have a difference of cubes? All right, Well, 2 is not a perfect cube. 54 is not a perfect cube. That should tell us something. They're both even numbers. We have a GCF. All right, so our GCF is 2. So we're going to go ahead and take that GCF out, and I'm going to do that right over here. So we end up with 2 parentheses x cubed. Again, we're just dividing the GCF to each of the terms, minus 54 divided by 2, which is 27. All right, and that's what we have right now. All right, so we've taken the GCF out. Inside parentheses, do we have a difference of cubes now? Yes, we do. Okay, so again, this GCF needs to stay on the outside. What number multiplies together 3 times to get x cubed? That will give us an A. Well, we know that x multiplied together 3 times gives us x cubed. And what number multiplies together 3 times gives us 27? 3 times 3 times 3, so B equals 3. And we're going to go ahead and plug this bad boy in. All right, and don't forget the GCF on the outside, which is 2. All right, so we end up getting x minus 3. Just plugging it. I'm literally just going back and looking up this formula. All right, and just plugging whatever A is, x, and whatever B is, 3, back into the formula. All right, and then A squared. So we get x squared minus, or excuse me, plus, because this is now difference of cubes, plus A times B plus 3x. And then last but not least, plus 3 squared, which is 9. All right, and this cannot be simplified. All right, you can go ahead and check the factors of 9 to see if they add up to B, which is 3 right here. All right, and you can't do that. So this is it. This is our answer. All right, this is as factors as it can get. Now we're going to see some examples here in a little bit where it can be factored further. All right, you might see this in your homework. Really, all you have to do is double check, hey, can I factor them? In trinomial factoring, is there another difference of squares? If there is, you just have to factor again. All right, you just have to factor it again until it's completely factored, and you can no longer factor the expression. All right. I'm going to stop here, and then I will pick up on one more video just to go over the rest of this factoring worksheet. Again, if you're having issues with this further, I will post some YouTube videos. Yay Math, I've showed you guys the video of that guy before, who's, by the way, I watched one of his TED Talks recently. He's an excellent teacher. He just tries to make it a little bit more fun. He does a great job of explaining this as well. So if we're still having issues, please email me at bryanarchbishopcurley@gmail.com, and I will make sure I forward those to you as well. But if you look up Yay Math on YouTube, you can go into Algebra 1, Algebra 2. Algebra 1 has all the factoring stuff, believe it or not. So you can go into Algebra 1. His Algebra 1 playlist has a long list of factoring, especially, I think he really focuses on difference of squares. But again, that's it. I will pause this video and start another one so that we can finish this up.